right, so today we are going to talk about change in tandem. What's that word tandem mean? It's not a word that we typically use a lot. Okay, in relation, that's good. You might think of like a place you've like heard the word tandem. Huh? What? Oh, you're right, skydiving. Yes, and what does that mean whenever you're tandem skydiving? You're hooked up to somebody, right? There's two things, and you're like, whenever you fall, they fall. Another thing you'll probably don't have a lot of experience with, but there's like tandem bicycles, and those are like the bicycles with the two seats, and you both try to ride the bicycle together. I've never done that before, but I've seen it. So this is going to be looking at the relationship between typically two variables. You can do more than two variables, but we won't really do that in this class because it's well beyond the level that we'll go to. We're going to start with something that you've talked about a lot throughout math classes, and that is a function. So this first blank right here says a function is a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly one output value. So whenever you do this, you start with this in Math 1. I realize that was like 8th grade for a lot of you, and 9th grade if it wasn't 8th grade. So it's been a long time, but whenever you start talking about functions, you use like a vertical line test. Now, I just used his notes, and I'm taking his word for it. In previous courses, you have used the vertical line test to determine if a graph is a function or not. Later in this course, we will learn that this test does not always work. I'm not so sure I learned last year why this does not work. Everything I've dealt with, the vertical line test works. I do know when it comes to our AP exam, they will not accept vertical line test as a reason for something being a function. While you can use it to kind of decide if something is a function, you have to explain it in words. So when we take our AP exam, for the Precal AP exam, it's more multiple choice than it is free response. But you will have 4 free response questions. And to give you an idea of like what they're like, you have an hour to do them. So it won't be just like a single problem. It'll be like there'll be a heading and there'll be like a part A, part B, part C. The good thing about the Precal is they pretty much tell us what the questions are going to be. They'll change the scenario a little bit, but they like tell us the format of each one, which makes it much easier than in calculus where I got an idea, but I don't have that sort of structure. So
there's 4 parts in one question. Or is it 4 different questions?
4 different questions, and each one of those questions have different parts. So it really ends up being more like 16 to 20 questions, depending on how many parts there are for each section. But on that free response section, one thing you're going to have to do sometimes is you're going to have to explain your answer. So you've probably not had to do a lot of writing in math class before. I know that whenever I teach math 1, 2, and 3, I usually do not make kids do a whole lot of writing. So it's not going to be complicated like beautiful writing. Your grammar and spelling are not going to matter as long as they can make out what you mean. But there are going to be some things where you have to write and explain what you're going to do. And we're going to practice that as we go, so you'll be okay with it. So the set of input values of a function is called the domain. What's my computer doing here? Domain. Okay. It is represented by the blank variable, and some of you might be thinking in your head, X, domain is X, right? Did any of you have Coach Wood for Math 3? So you would know that all your exes live in Texas. Did he sing that one to you? Because all my exes live in Texas, and Dallas is in Texas, and Dallas starts with a D, so X is domain. So it makes perfect sense. So he loved It's so sad that like next year there's not going to be any, there's going to be some kids that had them in like Foundations of Math 1. They won't be in AP Precal though, more than likely. So it's kind of sad. You guys have missed out if you didn't get the joys of being entertained by Coach Wood. So domain, typically it's the X variable, but it doesn't have to be the X variable. We're going to call it the independent variable. And if you want to put up here, usually X, that's fine. But we'll see them use T as the independent variable a lot for time. And they can use any letter they choose for it. It's just typically X. Yeah. The output values, the values you get out, that is called your range. And that's represented by the dependent variable. And it's usually Y, or they'll use function notation a lot. They'll use like an f of x or g of x or something like that. So those are typically what you'll see. But they could change letters to anything that they want. So, example 1 is just really straightforward graphing a function. So I'm going to even start with B over here because this should be something that you could do in your sleep by this point. So for B, you've got -4, -1. So -4, -1 is right here. We just put a dot. Then we got -1, 2. So -1, 2 is here. We got 0, 3. We got, oh, no, that's 3, 0. Hold on. Get it together here. 0, 3. And then we got 2, 3. And then 4, 1. You don't connect the lines on this because this is all they've given you. They didn't give you a formula or anything. So it could just be the point. A lot of times the functions we're dealing with are equations, which are going to be continuous, and you connect the lines. If they don't give you the equation, then it's just the points. So these points are your function here. They didn't ask us, but well, actually, I guess they didn't ask us because they tell you it's a function. This is a function. What would cause it to not be a function? If the x value repeats. So like if I had the point 1, 3, I'm sorry, not 1, 3, 0, 1 right here, then I'd have a repeated x value. You do have a repeated y value here, but that's okay. You can have repeated y values. You cannot have repeated x values for that. Okay, so this would be our function for B. For A, they gave us the equation in words instead of giving it to us in symbols. One big thing that AP likes to focus on, and it's really good for your mathematical understanding, is multiple representations of math. Because whenever you're talking about math, there are lots of ways we can represent it. What we're most typically familiar with at this point is an equation, f of x equals 2x plus 7 or whatever. But that equation could be made into a table. That's called numerically. We look at the numbers, right? It could be graphed. That's one way of looking at it. And then the fourth way of looking at it is through words, right? Which is the one we probably do the least in the other classes. So this tells us the function halves each input value and then adds 1. So one good way to maybe think about this is to think about making yourself a table. Like we've got x and f of x. So if I have an input value of, let's say, 2, I'm going to halve it and add 1. So I take half of 2, which is 1, and I add 1, so I'll get 2. if I do like 4, notice I'm picking even numbers, so I don't have to take half of a odd number. Half of 4 is 2. I'm adding 1. That'll give me 3. Maybe try 0. Half of 0 is still 0. Add 1. I get 1. So if I start graphing these points, I've got 0, 1. I've got 2, 2. I've got 4, 3. What do you notice about those lines, those points as we graph them? They're just increasing in a straight line, right? If we wanted to, we could write this equation, f of x equals 1/2 x plus 1 would be the equation for it. We could write it as algebraically. We could make it a table. We could graph it. And in this case, you're not restricted on what your x's could be, right? So we would want to go ahead and draw a line through this one, because it doesn't tell you what your inputs have to be. I was just guessing at numbers to make myself a table. It could be anything. We could have half of 1.725 and then add 1. So you would connect this for this one. Okay, so this should all be things that you've done before and are fairly familiar with. This next part, I know that in Math 3 you talk about increasing or decreasing. Did we do concave up and concave down in Math 3? I'm thinking no, but I also only teach regular Math 3, so sometimes there's things I probably should have done that I did not because we were struggling on the easier stuff. So I think increasing and decreasing is going to be covered in, I know increasing and decreasing is covered in Math 3. I think that concavity is not. But that might just be something I leave out. I can't remember for sure. And a lot of you are saying to yourselves, Miss Hyatt, you know that I had Math 3 first semester, sophomore year. It is silly for you to think that I will remember any of those things anyway. Because probably most of you had Math 3 first semester, sophomore year. So you're all mostly in the same boat, except for a couple of you who had Math 3 last semester, and you guys, so that's you two and Lewis, right, I think, and somebody else had Math 3 last semester. That's like the best way to do it. That's the, you don't forget things whenever you do that, but you'll pick back up quickly, and if you're not, like if there's something that you're like, I don't, you say I should know this, but I do not, let me know, we'll work on it. All right, so increasing, you always want to go left to right, and it's either just going up or going down. The official mathematical definition for increasing is that as the input values increase, the output values increase. So if A is less than B, then f of A is less than f of B. So like if we put the point A to be right here, then f of A would be over here, right? Because that would be the value that we plug in. And if I put B over here, then the point would be here. So f of B would be over here. So if you have a lower input value, you'll have a lower output value. If you have a higher input value, you'll have a higher output value. So that is the official mathematical definition of increasing, but most of the time we can just tell by looking at it, right? Whether it's increasing or decreasing. Decreasing is pretty much the same definition, but you'll notice that this sign has been flipped right here. So if A is less than B, f of A is greater than f of B. So whenever your input values get bigger, your output values get smaller, right? We'll be looking at this. Concavity, looking at it is fairly easy to tell. Concavity is whenever you're curved up or curved down, right? So here's an example of a graph that is concave up. This is a graph that's concave down. You may have talked about concavity like when you did quadratics. So you got like the smiley face parabola, that's concave up. You got the sad face parabola, that's concave down. But in this class, we're going to talk about concavity in how it works with your rate of change. Okay? So, for example, if I want to know the rate of change between 2 points, you do rate of change in Math 1. Does anybody remember a different word you used for rate of change? Slope. Slope is your rate of change for your graph, right? Y over x. Y, changing y over changing x. So if I think about going from like -4 right here to -3, if I think about the slope of this point, and I'm going to switch colors because I can, and then I go from 3 to -2 here, and then I go from here to here, and then I'll run out of colors here in a second. Here to here, and then I already used green, light blue. Like, it doesn't have to be at the whole numbers; they're just a good place to look at. If I'm looking at these like little slopes, right? Each one of these slopes. What I want to do is look at like what's happening to these slopes. This will be good enough. It would keep on going. So if I look at that slope of that purple line, I guess I could actually figure out exactly what it is. Is it positive or negative? If I have that slope. It is negative, right? Because if my line is decreasing, my slope is negative. Is it going to be, I have to be careful how I say this. Is it going to be a larger negative number or a smaller negative number? Like, is it going to be, like, let's say that one of these is -3 and one of them is -2. Which one's going to be the -3, the purple line or the red line? It's going to be the purple. The steeper it is, the higher the magnitude of the number. And I'm careful to say higher the magnitude of the number because -3 is actually lower than -2, right? Because they're both negative numbers. So, like, I don't think this is exactly -3, but let's pretend it's -3. Well, then that red line right there, that has a lower slope. It's still negative, but it's not as steep. So the magnitude of the slope is lower. Maybe it's -2. Again, I'm just guessing. I don't think these are exactly right here. Well, then, if that's -2, what would you think the slope of that green line might be? It's similar. Is it as steep as the red line? I think it's a little less steep, right? So, like, just for the sake of easy numbers, we could call it -1, right? Then, if I look at that orange line, it's not very steep. Still a negative slope, but needs to be less than -1, so maybe it's -1/2. Again, I'm just making up numbers for this. But the slope of those lines, I've got -3, -2, -1, -1/2. What happens whenever I get to that light blue line? Since this looks pretty symmetric, let's go with like, it's going to be a positive slope. That's going to be a positive 1/2. And then for my pink line, that'd probably be 1, right? And then this would continue to go on. Yes. Yes, steeper the line, the higher the magnitude of the slope. So if you ignore the sign, like the absolute value of the slope, the steeper, the higher the number will be. Yeah. So if I look at these slopes, my slope here, which is my rate of change, right, is -3, then -2, -1, -1/2, 1/2, 1. Those are increasing, right? Even though it kind of looks like decreasing right here, they're negative numbers. So if you're thinking about plotting them on the number line, -3 is down here, -2 is over here, -1, -1/2, and then you get to the positive numbers, right? So your rate of change is increasing. whenever you have something that's concave up. Okay? Concave down is very similar. So in this case, we would have, like, from here to here, we got that little section of line. And then if we just keep going, we got this little section of line. And then, I'm trying to say more of my colors. We got this. And then here. And then here. And here. So if I kind of use like the same numbers for this, I don't think it would actually be the same numbers, but just for the demonstration, this purple line's my steepest line by a little bit, not by much. So maybe that has a slope of 3. And then the red line is a little less steep, but still positive. So maybe it's 2. Maybe the green line is 1. Maybe the orange line is positive 1/2. And then if I keep going, then I switch to a negative right here at that little light blue line. And then maybe this one is -1, and that pattern will keep on going. So in this case, my numbers are decreasing right here. It may look like this starts to increase here, -1/2, -1, -2, -3, but keep in mind those are negative numbers, so think about where those are on the number line, not where they are here.
So it doesn't matter about like the numbers on the graph, it's just about how steep it is, and then like if it's decreasing or increasing.
Yes. Yeah. So this is something we want to remember. If our graph is concave up, our rate of change is increasing. If our graph is concave down, our rate of change is decreasing here. So let's look at some of the examples that they give us. Okay. I believe in Math 3 you should have looked at a couple different ways to write intervals. So like when I ask you if this graph is increasing or decreasing or concave up or concave down, you would give me the domain where that happens, the x values where that happens. So let's just do increasing right here, and then we'll talk about what to use for our domain. So if I look at where this graph is increasing, you can just look, make sure you start left to right. So increasing would be this section of the graph would be increasing. And then we decrease here, decrease, but right here we start to increase again. So whenever you're reporting the domain where this happens, you're reporting x values. It's easy to get mixed up and put the y value. For example, lots of kids would write -2 to 3 for the first section. But it's the x value. So you're going. It starts right here. It's -2 to 0. Okay. You got 2 options for how to write that. You can do -2, 0. I like interval notation better. Gosh, I can't remember. I think Precal does this different than calculus, which was causing my like AP classroom. My AP Facebook groups to lose their minds. But I'm going to go with what calculus does. I do know they're not going to, like, try to trick you up on this, or they'll accept both. In calculus, we would use brackets for this. I'm going to go back and look at this for Precal. I might decide to change that. What I do know is if they give this to you on the exam, and you do it incorrectly, like different than what they want, they're not going to count off for it, because there are textbooks that some of them use brackets and some of them use parentheses. So it's not going to be a big deal either way for that, because I want to say that they don't match, which is crazy. Why did they not make those two things the same? So you could write it this way, or you could do -2 less than or equal to x less than or equal to 0. Okay. Either one, I don't care which one you give me. I need you to be able to recognize both of those, because the AP exam may use either one. So they might ask you, is this function increasing from -2 less than or equal to x less than or equal to 0, or is it decreasing? You have to know where it's talking about. They may give you either way. But that is not our only place where we're increasing. We are also increasing right here from 4 to 7. So we can use the union symbol, which is just a U. And then we can say 4 to 7. Or we could do and. You could still do the U if you want with the bracket. That U says that it's both places. It really means union, so it means like this and this here. Yeah. So 4 less than or equal to x less than or equal to 7.
Do we need to put like D or domain, or is it like kind of understood?
For this, you would not need to put that because it's asking you where is it increasing, and it would be understood that you're going to answer that with the domain. Okay, so for decreasing, we're just looking at basically the other parts of this graph, this part right here, and then it decreases all the way to here. So for decreasing, we would say from, again, make sure you're going down to look at the x-axis. You would go from -4 to -2, and from, again, down to the x-axis or up to the x-axis, 0 to 4. Or you can write it this way, -4 less than or equal to x less than or equal to 0, and 0 less than or equal to x less than or equal to 4. Yes? For this part right here. Oh, I don't know. I've lost my mind. Thank you. That should be a -2. Okay, does this make sense? You kind of remember doing it before. That part is a Math 3 concept that we look at. Concavity is a little bit different, but it's pretty easy most of the time to see from the graph. So I'm going to erase my highlight because it's going to get a little bit confusing looking here if I don't. So if I want to know where the graph is concave up, do I have any concavity from -4 to -2? I do not. It is a straight line. It's not, your rate of change is constant, so it's not concave up or concave down. It just has a constant slope. So you wouldn't use that part of the graph at all. Concave up is going to be this section right here of the graph. Okay, so we would say, again, look at your x coordinates. So wherever you stop, go down to the x-axis. You would say 2 to 7, or you could say 2 less than or equal to x less than or equal to 7. Oh, I'm really unsure about the or equal to's on those. They might be parentheses, but I need to go back and look. Well, I can't remember. I mean, it's definitely like the point is included. As far as concavity goes, I know whenever I had calculus, my teacher taught me that like at the point, like at a maximum point, you're not like increasing or decreasing, you're switching, so you don't include it. However, other textbooks teach it a different way, and like calculus tells you to use a bracket there. I need to go back and look at the Precal stuff and remember. It might be parentheses, but I will tell you it's not a big deal. They're not going to give you like one answer choice brackets, one answer choice parentheses. If you write it out, if you use brackets where you should use parentheses, they're not going to count off for it. So I may be teaching you that inconsistently, but even if I am, it doesn't It'll be fine.
The greater than or less than, that's
You always, yeah, well, these are just like two ways of writing it. So that's the same thing, right, from 2 to 7 with interval notation, or, so I just did on different lines up here, but you could also write it this way. Okay, D and E, D is going to ask for increasing and concave down. So we have to think about both concavity and increasing or decreasing. So, let's see if it'll let me erase my, oh, why is it not working? There we go. All right, so I need to be increasing, but also concave down. So this is increasing. Is it concave down? Yes. So increasing, concave down, but I need to stop right here because at that point I'm still concave down, but am I increasing? No, decreasing. And then all of this is concave up, so it can't be part of our answer either. So for this, we would have -2 to 0, or we could write it -2 less than or equal to x less than or equal to 0. And then that last part says decreasing and concave up. So I need to be decreasing, but concave up. This part's decreasing, but does it even have any concavity? Nope, none. Here we're decreasing, but we're concave down. But right here, we switch to concave up. But at 4, we're going to stop because after 4, are we decreasing anymore? No, we switch back to increasing. So this would just be from 2 to 4. The biggest mistake I see kids make is they look at the y-axis instead. Like for this one right here, they'll say -2 to 3. Which is wrong because you're not using the y-coordinate at that point, you're using the x-coordinate at that point. So that's the biggest thing I see kids do wrong for this. Otherwise, they usually do pretty well with this if they get that straight. All right, any questions before we go on from that? All right, example 3 is harder. Example 3 gives you the information and wants you to sketch the graph. Okay? They tell you we're increasing from -4 to 1 and 5 to 7, decreasing from 1 to 5, concave up from 3 to 6, and down from -4 to 3 and 6 to 7. Now what I like to do for this is I like to make myself a chart. So I'm going to take every number I see here, -4, 1, 5, 7, 3, 6. I'm going to put it on a number line in order. Okay? So let's see. Our lowest number that we've got there is the -4. And then there's no other negative numbers, are there? So 1. And then 3, 6, and 5. We need 5. 5. Oh gosh, should have given myself more room here. Okay, so I like to do this, like just make myself sort of a chart here, draw me some lines up right here, and just do increasing, decreasing, and concavity. And so for my increasing from -4 to 1, I'm increasing. And from 5 to 7, I'm increasing. So that would be here and here. And then decreasing from 1 to 5, so that would be here and here. And then for concavity, I've got from 3 to 6, it's concave down. So I'm going to put concave down. And -4 to 3, I'm going to be concave up. And then from 6 to 7, also concave. Hold on, I've got that backwards, Norma. I've got these backwards. I'm reading it backwards, yeah. Alright. Change your arrows if you're copying me. From 3 to 6 is concave up. And or concave down from -4 to 3. And from 6 to 7. It might even be helpful to you to like put some vertical dotted lines right here. These are not part of my graph, but like they break it into the pieces of the graph. So -4, +1, 3, 5, 6, 7.
Wait, are these all the x values? Is that
Yes, they are
so,
x values.
-4 and 1 is both x values?
Yes.
Oh, okay.
Yep. So on my x-axis, I'm just like drawing these dotted lines to break it into the pieces of the graph that I need. So your graph can look a lot different than my graph because they don't give us any actual points on this graph. They don't tell us how steep it is, how it just has to look a certain way, right? So between -4 and 1, I need to be increasing but concave down. So you can start wherever you want. Let me use a different color for this. Let's make it blue. You can start wherever you want, and then you have to be increasing but concave down until you get to 1. And then we go to decreasing and concave down. So this is going to be like a maximum point here. I need to decrease and be concave down. Yes? It just because I picked that point. So you could start it anywhere that you want. So it could, and like as far as it's stopping right here, you have to have a maximum point there. But if you want to make it steeper or less steep, or the whole graph is up higher or lower, it doesn't matter because they didn't give us any actual points for this. So I just randomly picked a point to start at. I knew I needed to increase, so I started lower. You wouldn't really want to start at the very top of the graph for this because you'd run out of room. It's the only thing you wouldn't want to do for that. Good question. All right, so decreasing concave up. So I'm still decreasing, but it's going to switch to concave up. This is sometimes a little hard. You want to make it pretty drastic that it's concave up there. Don't make it look like a straight line. You want to curve it up some. Then we go to increasing concave up. So if we're switching from decreasing to increasing, that means we got a minimum point here. We're just going to keep that curve on going there. And then the last part is increasing but concave down. So still going up, but turns back down like that. Now, your graph may be more stretched out. It might be a little bit different, but you definitely should have a maximum point right here at 1. You should definitely have a minimum point right here at 5. It might be above the x-axis, below the x-axis. That doesn't matter, but it needs to be a minimum point. And then you're going to have what we call points of inflection. I don't know if you've heard that term or not before. Places where you change concavity right here at 3 and 6 for this. These are a little trickier. You got a lot of stuff to piece together there. Good news is they're probably not going to ask you to do this on the actual exam because it's too hard to grade. Now, I might on my test because I will be grading it. But
so for like all these, they're just x values, and there was no like y.
Right. The y value that I have here is just arbitrary. It could be anything as long as we're following the pattern. But the x values, those have to be right on. All right. Okay. So if we're talking about rates of change, we already talked about concavity and our rates of change. If something is concave up, the rate of change is increasing. So the slope is getting higher and higher and higher, right? I wouldn't say steeper and steeper and steeper. but that doesn't really take into account negative slopes, right? Your slope, the number of your slope is getting bigger as you go from left to right. Yeah, so it might be like -3 up to the +1 like we saw. All right, concave down, your rate of change is decreasing. Now, the first part of this graph is even a little more simple, right? If a function is increasing, so it could even be a straight line, right? If it's increasing, what do we know about the slope of that line? What does it have to be? If it is a line, it is going to stay the same. If it is an increasing line, what else do we know about it? It's positive, right? So it could look like this, where you have like a constant line, or it could be something like this, right? So for this, your slope's not staying the same, but because you're increasing, all these little slopes, if we did like we did on the others, if we like drew them in, they're still positive, right? They're positive slopes. So if your function is increasing, then your rate of change is positive.
But it's not
It depends on concavity for increasing or decreasing. So it could be constant, it could be increasing, or it could be decreasing, but we know it has to be positive. Okay? And then so if our function is decreasing, our rate of change is negative. This chart right here is good to like sear into your memory. Like you need to know this. So, for example 4, it says a table below describes describes the rate of change of a function. For which interval is the function increasing and concave down? Now this table, does it talk about the function? Is it giving you x and f of x? No, it is giving you the rate of change of the function. So if our function is increasing and concave down, we have to think about what that means for our rate of change of f. If our function is increasing, what's it tell us about our rate of change? Positive. And if we're concave down, we'll be decreasing. So we're just looking for positive and decreasing here. Positive and decreasing only happens right here. 1 to 2 is your answer for that. So you got to be really careful whenever it's asking you about the function, but it's giving you the rate of change. Okay? All right, so here's another way they might ask a similar question. The function g of x is graphed to the right. Give the open interval where the rate of change of the function is negative and decreasing. It is not asking you where this function is negative and decreasing. If it were asking you, it would be right here. Negative means it's below the x-axis, and that's decreasing. It'd just be that piece right there. That's not what it's asking you, although they do give it to you. Well, they didn't give it as answer choice. A lot of times they will. They're asking you about the rate of change. So if my rate of change is negative, what does that tell me about the function? Decreasing. And if my rate of change is decreasing, what's that tell me about f of x? Concave down. So this question is asking for where this function is decreasing and concave down. So decreasing and concave down, we're looking at this part of the graph right here. And that's probably it. I would assume that this is the point of inflection here and switches to increasing there. So from -4 to 1 and B would be our answer. I left the calculator tips here in the notes just in case they ever change their mind. I don't have to go back and redo that for my notes. You can kind of ignore that because we're just going to use Desmos. And this last one right here, whenever you have one like this, I'm just expecting you to use Desmos. Desmos makes this so much easier. I don't think this will be a difficult problem for you guys. I realize it's about time to go. But like all you will do for this is you will just type in the equation. You will probably need to use X instead of T. Sometimes it doesn't like the T's. And you're just going to graph this and like look at the answers. Like your maximum height here is 16.228. It's 2.26 seconds. I know I'm going through this too fast, but the answer is D on that one if you want to go back and look at it. You're really just like reading those points off of the graph for that. So I think you'll be fine. Yeah, just graph it on Desmos. It's got the calculator tips there. Do not worry about those. We get to use Desmos. I just didn't want to take it off and then change it.
Do we need to graph it or like?
Probably because you got some answer choices you won't be able to like tell between unless you do that. So
like on this problem or like
on that one you will because you wouldn't be able to just like know what it's going to be. Some of them they'll give you the graph or you'll be able to do it. All right, this homework assignment looks long because everything he does looks super long. Because he makes a lot of multiple choice and there's a lot of graphs and stuff, but it's not as bad as it is. 2 truths and a lie. 2 things are going to be true, 1 is going to be false. So you're just picking the one that's false for each one of these, okay? So each one has 3 statements. You pick the one that's false. And I think it might say fix it to make it, or tell why it's false for that. The key's posted, so please check this tonight before you come in tomorrow.
Listen, on the parent thing, I might put my dad's phone number instead of my mom's, but I think if you just call me.
Okay, either one's fine. Sometimes there's not much difference. Sometimes there's not. So 3 to 5 needs to be decreasing, but I think it should be. So from 3 to 6, it's concave up. Oh wait, did I draw it wrong? I may have done it wrong. All right, so no, let's see. From 3 to 5, you're decreasing. Increasing concave decrease. So, okay, it needs to look like this. From 1 to 3, you're decreasing, but concave down. So this should like turn like this. It should be like this. And then this one will be decreasing but concave up, which will be, it'll look like this section right there. So it'll, let me just draw it in so you can tell. There. It'll be, this part right here will be like this because it should be concave down, and then it'll switch to like that. Does that make sense? Okay. Yes, go ahead.
So for this one, 5, is it decreasing just because it's going this way? Like, is that like -4 to -1? That's like a decrease for X.
They said that
probably after it's going this way. Like if it continues on.
it's going down. So like your Y value. So you start on the left side and you go to the right side.
And it's concave because it's like this.
All right. Oh, I'm still recording.